the chat. Okay, and the meeting has been excellent. Okay, visual testing using Cypress is a topic of passion for me because I love visual testing. I think it's extremely effective. And when you combine it with functional end-to-end testing, it could do wonders. You can find me online. I've been working at Cypress itself for 4 years, and I've been using Cypress for a year before that. And okay. And if you want to argue with me or agree with me, you can find me on Twitter. Before we begin, I would like to kind of start like I usually start with a reminder that despite COVID, we have not slowed down greenhouse gas emissions. So we probably will hit 1.5 degrees Celsius in the next 5 years. Every degree after that probably will displace 1 billion people. Like the stuff is extremely serious. And like fortunately or unfortunately, the answers are surprisingly simple. We have a technology to eliminate 90% of greenhouse gases. We just have to act. You can change your life, but more importantly, join an organization. There are lots of them fighting for survival of the planet. Find the one, go to the meeting, attend it virtually, do little things, and together we can solve it. Okay, slightly back to the topic. I had a long and pretty interesting career where I went from computer vision, C++, all the way to the browsers. And then I started doing everything with JavaScript. You can find all my projects on GitHub. I blog a lot, and I do argue about technologies a lot on Twitter. All my presentations are on slides.com. And these slides are there, so they're public. You can take a look at any time. Okay, so the Cypress itself is a great company. We grew it to about 50 people. I'm in Boston, but majority of people are remote or are in Atlanta. That's where it was founded. And we work on Cypress to make it the best end-to-end test runner for anything that runs in a browser. You have a static site, should be able to test it. You have every framework that you threw up, in that list, including, Dojo and Google GWT can be tested using Cypress. If you never used Cypress before, it's as simple as npm install dev save dev Cypress. So it's a normal npm installation, just like any third-party module. And when you install, it actually downloads a binary that we built for your operating system. Okay, so we built it one for Linux, for Mac, and for Windows 32 and 64-bit. And everything I'm about to show you is absolutely open source and under MIT license. Okay, so there's no commercial presentation in this slide. And if it's the first time you install Cypress, you probably want to look at our introduction to Cypress to understand how typical tests is written, how it runs, and so on. But this is full end-to-end test, right? We use Mocha syntax, so we use it and the name of the test. And the callback are all commands that you want to run in a real browser that simulate how the user would visit this page. It could be localhost or remote host. Then you want to find something using CSS selector. So in this case, find all elements with class new to do. In this case, it will be only one input box. And then we type learn testing followed by enter. Then we type more. So we use kind of jQuery, Fluent, chaining syntax. If you want to work with element, you just chain commands. Everything is of this global object side that we inject automatically into the browser. After you enter a couple of to-dos in your to-do MVC app, you probably want to get all list items and confirm that there are 2 of them. So load real page, enter a couple of to-dos, make sure that the application is working and displays that number. Full end-to-end test. And this is how it runs and looks in your browser. So Cypress comes with built-in Electron browser, but if it finds any browser installed on your machine, it will use those browsers. Firefox, Chrome, Edge, not Safari though. And then when it runs, this is the browser window that you see. On the right, you see the iframe with actual website under test. And it's a real browser, so you can interact with the application. On the left, you see the test itself. So remember, we named the test adds to-dos. So you see the name of the test on the left. Then, you can use your hooks for visiting, but you can see the commands: visit, get selector, then type again, and then get selector and green assertion. So everything from this spec file will be reflected in the what we call command log on the left. So you know what the test is doing as you see the application changing on the right. So that was Cypress introduction, right? And for more, you can find Cypress documentation. But for this presentation, I want to specifically focus on visual testing. Why is it even needed? What are the main principles for visual testing and its implementation? And then we'll look how to do visual testing yourself a little bit, and especially for complicated things like how do you test HTML5 Canvas elements. Okay, so let me ask you a question. And, here's Amazon.com. And I want to ask you if you can even log in into this page. Notice that the sign in and the label for the email is slightly misplaced. So it actually covers part of the input box. And if it covers that, maybe you cannot even focus on that input box, or you cannot type. Can you sign in? But more importantly, would you even try to sign in? Or would you think that something is wrong and maybe this is a phishing? Oh, not a phishing. It's like an impersonation attack, like an iframe attack, right? If you go to Amazon and you want to buy this TV, would you actually click the buy button? But notice on this page, it's not a buy button. It says buy now button, right? And underneath it has this lock and secure transaction label with a wink emoji. Would you actually trust this site to sell you this TV? Or would you think that something is wrong? So all bugs like this or errors like this, they break user trust and they lead to loss of business. And more importantly, they're very hard to verify using traditional functional assertions like I showed, like should have length 2 and so on. Because in this case, you probably would have to validate that every element on a page has the text you expect. You have to hard code it, right? And what about everything else? Things that are not labels, things that are not text, things like styles, layouts. How to actually verify those properties on your page and do it quickly? But doing it quickly is very important because manual testing doesn't scale. Imagine if I ask you to go through entire Amazon.com to make sure nothing looks wrong. That's absolutely out of the question. It doesn't scale. You cannot expect your developers or even your QA team to notice all the little details. Even small applications like
I do. Is the video off?
Like this Sudoku will have a lot of screens and a lot of UI elements that can go wrong. You would have to look at all possible user case scenarios and user stories at every resolution, because your application might actually lay out and show different things at each resolution. And the functional tests themselves, right? The things that I showed, find me the elements, check the text. Find me elements, confirm the number on the page, are not very helpful. For example, I can take a to-do MVC application that we had, right? And I can comment out CSS file, right? So the CSS would not even load. Well, guess what? The application looks completely broken to every user. And yet the functional test still passes because there's still input box. You can still type, click enter. It will add a new to-do item. It just, everything looks like a mess, right? But the functional tests still pass because they don't look at the styles. They don't look like at the layout. And if you try to write functional assertions to confirm CSS and style and layout properties, it quickly overwhelms you because you would have to check everything and every possible CSS property. Doesn't scale at all. So we need something else. And this something else is visual testing. The main idea behind visual testing is that instead of doing functional assertions, we're going to render the page or, its part, like a single element, into an image. So basically, like, take a screenshot of a page. So now we have PNG image. And then we will compare that image to a previously rendered and approved image. An image that some user looked at and said, yeah, this looks good. Let's keep it as a baseline. So now we will compare the new image to the baseline image. It can look like this. So imagine this is our baseline image. We have a drop down, we open menu, took a screenshot. Well, now in a feature branch or in a particular new commit, we take an image of the same drop down after we open it, and all of a sudden we see all this navigation header links below. Now, it could be an accident. Maybe some toggle is gone. But it could be a new feature we actually could have added was headers. But before we decide, we have to take an image difference. So we take a delta, we compare those images pixel by pixel, red, green, blue, channel plus alpha. And so we go through each row and each column, and we compute which pixels have changed. And majority of pixels have not changed, right? Everything is the same except for the bottom part of the dropdown. And so usually those visual dips are images with red pixels kind of marking the spots, the pixels that are different, where the new image is different from baseline image. And now you, the QA, the developer, have to kind of look at this diff and say, did I intend it to do? Or did I intend to change the appearance or layout or color? And so you can say, no, this was a mistake. Thank goodness that you caught it. So we can reject the difference. In that case, the test fails. Or you, the human, can say, yeah, this is a new feature. We added new navigation menu items. So I accept this. In that case, the test passes. And also, that new image becomes the new baseline image. So from now on, we're going to compare new, tests for dropdown against this new baseline image. So the visual testing replaces this very hard to answer question, does this page look good to a human eye, with a much simpler question, does this page look the same? And this question, does this page look the same, is very hard for humans to answer, right? We would kind of look through the whole page and it just would take forever, and we'll definitely miss a bunch of things. That's why kids love always find 10 differences between those two pictures. But computers are extremely efficient and fast at image comparison. They literally can just scan the whole array of numbers and say these two numbers are different. Easily parallelizable, easily scalable. Okay. For one question that people ask is, how many images do I need to actually cover my whole application with visual tests so that we can, catch all those login problems. We can catch all the buy buttons problem. So my advice is usually take every user workflow that you have, major user stories. And when there are visual changes that are, nice, changes through the user story, take a full application screenshot. And of course, if, for example, you have a header and you don't care about the header for the user story, you can limit yourself to just the main area, but take a screenshot every time something changes. And if you have multiple resolutions that you support, make sure you take every user flow again at each supported resolution, because your appearance on a mobile and your appearance on desktop can change independently, and you don't want to miss the errors because you never actually took screenshots for mobile resolution. If you have component tests, right, those drop downs could be a component that shows one item, two items, subheadings. Take visual tests for each different state of a component. So even in Sudoku, I have 15 images, right? So it seems like a small application, but the number of images quickly multiplies because there's so many visually different things. So this is how Sudoku looks when we start a game, right? The field, for example, in this case, will have 45 grid cells field, and it has the timer 00 and a status bar on the right. If we make a move by filling a cell, then it will also highlight other matching numbers, right, on a field. So 666. So this is a different visual appearance. So I'll take a screenshot. When we are about to finish the game, I probably will take a screenshot just to show how the full field except one cell looks. And when we fill the last one, then the game shows us you solved it in the screen. So I'll take a screenshot here as well to make sure that my game always ends up here and visually nothing changes accidentally without me knowing it and approving it. Because the game looks and the layout is different on each resolution, I'll take different screens, a tablet and mobile resolution. And my component, that status bar or status column on the right, it can have toggles. So I will take the same status bar component and I will change the toggle states in my test, and I'll take visual screenshot of that component to make sure it doesn't accidentally change. Okay, so this is kind of nice, right? Just take screenshots, compare them. Visual testing presents a bunch of challenges. So the first challenge that you'll encounter in a complex application, comparing two images and make sure they're pixel perfect and are the same image, is only possible if application is rendering the same data, right? Otherwise, pixels will not show the same. So you have to make sure that the application is showing the same stuff. That means if you have dynamic data, think all your fake dynamically generated usernames. Cannot have that, because different name in the input field will show different pixels. If you fetch something from the server and you don't control that, the data from the server, the response, you'll have different data rendered on the screen, pixel differences. If you have a clock ticking somewhere and the timestamps shown, different data, pixel differences. So luckily, Cypress provides a lot of mechanisms for controlling the network, mocking data, and controlling the clock. So those things are they're easier to do with Cypress. But then besides that, there is performance question. So imagine you have a larger application and you don't have 15 images, but you have hundreds of images. Generating them, comparing them becomes a performance issue because it will slow down your functional task if you have to generate, compare. You also will hit a problem where even generating a consistent image is a challenge by itself, even with the same data. For example, the same browser will render a complex page differently on Mac versus Windows versus Linux. And everything depends on fonts installed, configuration, system libraries, GPU, There's tiny differences in the way browsers work, in different modes on CI versus locally running tests. So deterministic rendering is a huge problem. And just to figure out what's your workflow for running the tests. If you have a baseline image, where are they stored? Do you commit them to the repository? Do you keep them somewhere else? When you approve a visual div, right? How do you do that? Where does the image go? Does it override things, right? These are all questions that you have to figure out in order for your team to start using visual testing. There are lots of options, but different ways you can go if you want to try visual testing. So I've written the guide for Cypress that you can check out, and many commercial services wrote plugins for Cypress that you can use, so you can start writing visual testing right away. The most important number one question you have to answer to yourself immediately is, do you want to do it yourself? Or do you want to go with third-party commercial service? That's a number one choice. Everything after that is kind of depends on what you picked here. Okay, so let me start with third-party service, right? The third-party services, the commercial providers, they don't even take the screenshot on your local machine because that's hard to generate deterministic image across different platforms. Instead, they take the DOM snapshot, right, the HTML, CSS, and like all the styles, and they just send it to their third-party cloud. Okay, that's why they will render the image consistently because they use the same browser locked on the same machine. So every time you render from that DOM snapshot themselves, it will give you the same pixels. Also, because they have a cloud of machines, if you send them hundreds of images, they're all be split and queued up and processed as quickly as possible. Now, the baseline images in that case will be stored on the third-party image provider, right? So you don't have to store anything or update anything. You can say, yes, approve, and the image just becomes the new baseline image. You don't have to move any physical files. And because this process is usually asynchronous, you don't have to wait for your test to pass, but that means you don't actually know if there are visual tests that failed, right? So usually you would have, let's say, GitHub checks. One check will come from functional test, and then asynchronously another status check will be updated by this third-party service. Most of the services become expensive very, very quickly. They all give you a free tier. Like, the free tier is enough for small projects to try it out. For small project, it will be enough to actually run it because you only need like a big screenshot. You don't need that many of them. But I do recommend you start with using a third-party service. And full disclaimer, I have a doctorate degree in image processing. I don't want to do it, right? It's something I would rather pay and not worry about and just start using as a tool for my testing rather than like create it from scratch. Okay, here's how a typical test looks when you use third-party service. So we're going to visit the page, right? This is our kind of standard command. And then, for example, at some point inside the test, I'll say sci.PercySnapshot. This command, PercySnapshot, comes from Percy plugin. And Percy is a very commonly used third-party image testing service. BrowserStack bought them last year. If you use Applitools, which is extremely popular third-party visual testing service, look at the tutorial. They provide their own custom Cypress command called eyes_check_window. There is Hapa.io, same thing. Just select a page or an element and take a screenshot. I've done webinars with each company. You can check them out, see how it runs in action. But let's say you have convinced yourself that you can do it. You decide to go do it yourself route. You don't want to pay anyone. You don't want your images to be stored anywhere on a third-party cloud provider. So you want to be safe and sound. Cypress includes a size screenshot command that takes a screenshot of a page or a part of a page. So you can take a screenshot of a whole test runner. That's probably not what you want to do, right? Because you don't care about the command log. You just want to have application. So a simple size screenshot will just give you like the app screenshot of a whole page. Or you can select an element using site get and then say dot screenshot. And that's how you take a screenshot of, for example, a single element. So those screenshots are saved locally as PNG files. And I kind of go through the whole setup if you want to do it yourself in a blog post. But then you have to manage those files yourself. You have to commit them to the repository. If you change the baseline by approving an image, it means like physically moving the image to that folder. And you have to think how you render images. So here's, for example, on the left, there is Mac rendering timer in my game. And on the right, a Linux CI rendering the same timer. To me, they look identical, but notice the image diffing in the middle shows that the outline of the font characters is different. And in red, these are pixels that are really different according to my image pixel comparison. So you have to think how you're gonna render the same image deterministically on different platforms. Luckily, you can use a Docker image even locally and run your tests there, and those will generate very good images as baselines that will be consistent, because on CI you can run them, a Cypress test in the same Docker image. But then again, like this is just like workflow becomes more complicated than necessary. There are plugins for image comparison and even Cypress plugins for doing the image comparison yourself, right, locally. So you have to find it. It's just extra complexity, right? So just ask yourself, is it worth it? How much time am I spending doing this rather than actually working on my application? Okay. So the one project that I'm excited right now about that started last year, and they just released version 5 already, is called Visual Regression Tracker. So this simplifies image comparison and management if you're doing everything yourself, okay? So they still take the screenshot using size screenshot command. That means they haven't solved non-deterministic rendering problem. So rendering would not be consistent across operating systems, but they solved everything else. So they give you a Docker Compose file, and when you start it, it has a Docker image for your database that keeps all information about your project, keeps all the images there, and even gives you a web application with login where you can review images, approve them, and then it like updates it in the database. So it takes care of all that, jazz about storing images, image approval, and so on. Here's a typical test for Sudoku game. Okay, so my block of tests is called Sudoku, right? And my test is called shows the initial game. And the first thing I do inside this test, I say VRT, which is Visual Regression Tracker, start. Kind of establish connection to my project running locally. And you can do it outside the test just once. In this case, I only have one test, so I'm starting inside the test. I want to stop the clock. So Cypress command sided clock freezes the application clock. So there is no timer running, nothing. And then instead of generating a random array, which is what games do, I use SciFixture to load local JSON files, which I saved myself before, for the initial board and the solved board. And I visit the page and I set those JSON objects on a window object. And my application knows that when it's running inside Cypress and those arrays are present on a window object, take them instead of generating a new board randomly. So this is the way I mark my data to remove the source of randomness so that my image is the same. Okay, so I loaded the page, and then I have a couple of assertions to make sure the board is there, all the grid cells are there, the status timer shows 000, and the difficulty shows easy. Okay, so after that, I take a screenshot. So I do VRT track, which is a custom command that comes from Visual Regression Tracker NPM package, and I call it Sudoku. And this is a wraparound size screenshot under the hood. Okay, so this is what it looks like when it runs. Notice on the left, I have like VRT command started, tracking Sudoku, and so on. When I run it first time, it just says, okay, I don't have a baseline image, for Sudoku. I'll just store that image in a database, and that's it. And this is the UI for Visual Regression Tracker. As you can see, I'm running this locally, but you can run it in a cloud, right, on your company's, internal machine. And you log in, and for this project, it says, here's an image. It's called Sudoku because I use that name. It was captured using Electron and so on. Okay. If I rerun the test and I haven't changed anything, on the left, you see baseline image. On the right, you see current image. They're identical. I haven't changed any styles. I haven't changed any numbers. I haven't changed the layout. So there's a match. The test is green. Now imagine that I change something. So normally it would be changed in application. But in this particular case, I'm changing the data. So I'm changing one of the numbers on the initial board, and I went to the difficulty drop down, and I select medium instead of easy, and I flipped one of the switches. So when I run this after this change, here's what will happen. Cypress shows in the browser, right, that VRT command actually failed, right? It says, hey, there are differences in the images that I observed, and here's the URL. You can look at the URL and go there and see the actual differences. So if I go back to the that URL, it shows there's one unresolved image, meaning the new image that I'm comparing is different compared to the baseline. And I can click on this, and this is what it shows, right? And on the left, it shows baseline. On the right, it shows the new image, and I can toggle the thing to show the actual diff, like all the red pixels, right? And you can see there is a new number, 9 changed to 8. The difficulty changed to medium, right? And one of the toggles at the bottom also changed. So it was able to detect all those little things. Now I can click approve. I can say, yes, I wanted this change to happen, right? In that case, I can go back to my test, rerun it, and immediately it's green again. Even though, those new things are still there, it's just my baseline is the new image, all right? So this is how you would approve an image if you really intended for this to be a change. Every time you take visual tests, you still have to fight flake. Flake meaning tests will sometimes pass, sometimes fail, even with visual testing. And usually in visual testing, things are flaky because the animation hasn't changed. So for example, here I took the image, and you see the new image, the inside area hasn't expanded yet. So visually, it's different image. Maybe the drop down, right, hasn't rendered yet, and yet I took the image too early. The text hasn't rendered yet, like all the icons are rendered, but none of the text. So this all will lead to flake. So the best advice to fight this flake is to first do a couple of functional assertions. The text is there, the grid is there, the text is visible, and after you pass those assertions, then you take an image. and now you compare them pixel by pixel. By then, you know that animation, class, all already has been set, application finished rendering. Now you can do image comparison. The HTML5 Canvas presents a particular problem. Everything I showed before, you can add a functional assertion. But what do you do when you have a canvas? Complicated chart, or in this case, very simple canvas with just a smiley face that animates. How do you do image diffing in this case? And again, I have a blog post and open source repository showing this. We cannot even look inside the canvas. It's a single element with just pixels. How do we do visual testing in this case? Well, before we take the image and compare it to the baseline, we can actually hardcode a wait, right? I know there's animation for a smile. I'll hardcode 4 seconds, and then I take an image and compare it. So I'll wait, animation finished. Now I take the image, and it matches the baseline. Again, waiting, animation finished. Okay, the same. Well, if I try to wait for just 1 second, if I try to speed it up, all right, then the images are different because my animation hasn't finished, right? And those red pixels showing mismatch. Especially on CI, I never know when things are done or not. Okay, so before we do this next step, I want to explain something that's a key characteristic of Cypress. Cypress has what we call retriability. In the first test that I've shown, we have a command to find all elements with this selector. Okay, and then we have an assertion. There should be 2. So this doesn't immediately check if there are 2 items or not, and if there are not, then it fails the test. Because we know that on the web, nothing happens immediately. So instead, Cypress has this approach where if there are no items or assertion doesn't pass for whatever reason, it will go back to the command like get, run it again. Maybe it will get a different number of elements and then evaluate assertion again. So all commands that are safe to retry if assertion attached right next to them fail will be retried. So even if my application is slow in this particular moment, maybe it goes to the server and the server is slow to respond, we don't fail immediately. We retry up to like default command timeout. All right, so in this case, we keep retrying, as you can see in blue on the left. And whenever application actually renders us, then the test passes. So we call it retriability. We can do visual retriability for our test to fight all the flake and not hard code waits. We need to take a screenshot, compare it to baseline. If it matches, all good. Continue to the next test command. But else, if there is a mismatch, we can check if we're out of time. If we're out of time, we fail the test. Else, we go back to take screenshot, comparing again, right? Because taking a screenshot and comparing is non-destructive operation. It's almost like querying, right? Is it the same? Is it the same? No? Okay. So here's how it looks. And I wrote this little utility called Cypress Recurse to do like retries for Cypress easily. So in this case, we'll go to the smile page and we'll call recurse. And it only needs 2 arguments. The first one are Cypress commands that you want to run. In this case, take an image, compare it to the baseline. And this will return an object with a match property, and we just return match. So this is the predicate. If it returns true, we know recurse finished. If not, it will go back to the first function and try it again. So here's how it looks. Notice on the left, it keeps retrying, taking an image, comparing it, retrying. And when the smile actually looks like the smile has finished, then it finishes the test because it just found an image that looked like the smile we expected. We can factor out all that common code, and then it's so easy, just say it looks the same, and it will rerun visual comparison until it times out or matches the baseline. And we never have to explicitly hardcode the waits. We can even automate this inside the browser. So we don't go to the baseline. We know that our animation is still continuing. So we can compare first canvas, wait, take the canvas again, and do image comparison pixel by pixel in a browser, right? And we can automate it where we keep taking the image until the number of different pixels is above a threshold, and then we can log the things. So basically, we can ensure the canvas is static. There are no visual changes because the pixels don't match, and then compare it to the saved baseline image, which kind of looks like this. Notice the number of pixels that are different, so keeps going down, and then we compare the image to the baseline. So we kind of wait for application to finish updating, and then we can take new image and actual comparing to baseline. This is extremely important for any complex animations and complex apps like charts. So here I will compare the chart as a loaded. I will add a data set, compare it to the new image, and then add one more data set, compare it, then remove data set. So do like complex user interactions with my chart, with my application, and compare at each step to what I already saved because there were good images. So here's how it looks. Notice the complex animations, and I never hard-coded any weights. Instead, I keep comparing the images. Once it matches that particular, kind of baseline at that particular step, I continue to the next. If at any point my chart did not look like I expected, the test will fail because the images never finally reached a consensus. Okay. Yeah, visual testing is simple like that. Super powerful. I never go into details. I just should look like that always. Okay. So this is the end of my presentation. If you want to know more about visual testing, I wrote a guide. I have several presentations, so you can find the slides for those. The slides are good because it actually includes a bunch of little videos. I have blog posts, and I also have a few videos on my YouTube channel, because when you do visual testing, it's much, much better to just look at someone actually showing it in action than even reading it or looking at a static screenshot. Okay, thank you very much for listening, and slides are online. If you have any feedback, let me know. I'm Gleb Bahmutov. Take care.
Great, thanks, Gleb. All right, thanks everyone for tuning in, and hope you got a lot out of it. This was pretty awesome. Just want to let you know that June 3rd, next Thursday, Travis Neslin will be giving a talk on incremental static bundling and Next.js and Vercel. And then 2 weeks from now, Casey Wilson will be giving a talk on AI and JavaScript with TensorFlow.js. So thanks again for coming. Thanks again, Gleb. And check your inbox. I got a little gift for you. So have a great day. And all you guys have a great afternoon. Thanks.
Cheers.
Thanks, everybody. Thanks, Gleb.
Cheers. Bye.